Applying relative gravity to atomic particles. Exploring the principles of relative gravity and relative equilibrium in the context of atomic and particle theory offers a fresh perspective on the nature of matter and the periodic table. By treating particles and atoms as dynamic systems influenced by field interactions, equilibrium states, and radiative dynamics, this model moves beyond traditional static, mass-centric approaches. Let's delve into its implications. 1. Particles as radiating gravitational bodies. Relative gravity at subatomic scales. Subatomic particles such as protons, neutrons, and electrons emit energy fields, manifesting as gravitational, electromagnetic, and nuclear forces. The equilibrium of these radiated fields governs the stability and behavior of particles within atomic systems. Hypothetical radiative matter. Particles are conceptualized not merely as points of mass, but as radiating energy bodies where gravitational fields interact with fundamental forces. For instance, the electron's orbit around a nucleus is influenced not only by electromagnetic forces, but also by gravitational field equilibrium at quantum scales. 2. Relative equilibrium in atomic structure. The equation for relative equilibrium, M1d2 equals M2d1, provides insights into force balance within atoms. Electron-nucleus interactions, the nucleus, M1, and electrons, M2, achieve stable configurations through the balance of radiated gravitational and electromagnetic fields across distances, D1, D2. Electron orbitals align with these equilibrium zones, where the nucleus's radiative potential matches the electron's field energy. Periodic table and orbital configurations. The periodicity of elements reflects these equilibrium states in multi-particle systems. As new protons and electrons are added, the system recalibrates, forming new orbital structures. This dynamic perspective enhances our understanding of the periodic table. 3. Hypothetical matter and the periodic table. Expanding the model introduces potential for novel forms of matter. Exotic elements, hypothetical particles with unique radiative properties, could create atoms with unconventional bonding and stability, such as gravitational isotopes that modify nuclear forces. Isotopic variability. Isotopes might not only differ by mass, but also by the strength or pattern of their radiated fields, enabling the possibility of stable isotopes beyond the conventional periodic table limits. 4. The mechanics of subatomic induction. Subatomic particles could function as miniature engines of field induction. Quark dynamics. Within protons and neutrons, quarks balance their radiated fields, while gluons mediate the strong force, ensuring equilibrium within these zones. Particle interactions. Interactions such as electron-photon exchanges involve field energy alignment, transfer, and re-equilibration. 5. Big Bang and particle formation. Relative gravity provides a new interpretation of the Big Bang. Field superposition. The Big Bang may represent a moment of maximum field superposition, where potential fields coexisted in a singular equilibrium. Particles then emerged as localized equilibrium points as these fields differentiated. Matter-antimatter symmetry. The imbalance between matter and antimatter could arise from differences in radiative potentials, where particles and antiparticles exhibit slightly shifted equilibrium properties. 6. Unifying atomic and galactic dynamics. By scaling relative gravity principles, we uncover parallels between cosmic and atomic dynamics. Galactic threads as atomic bonds. Just as galactic arms represent equilibrium zones for stars, atomic bonds represent zones of radiative field alignment between atoms and molecules. Gravitational and quantum field unification. Gravitational fields, though weaker at atomic scales, integrate with quantum mechanics to stabilize particle interactions, offering potential foundations for quantum gravity theories. 7. Implications for advanced materials. This model could revolutionize material science. Superdense matter. Materials stabilized by intense radiative gravitational fields may exceed current density and strength limits, enabling innovations like superhard materials or gravitational shielding. Quantum gravitational crystals. Crystalline structures with aligned radiative fields might exhibit extraordinary properties such as room temperature superconductivity or enhanced quantum coherence. Nasher. 8. Relative gravity and the search for new elements. New elements might emerge in environments with altered gravitational dynamics. Expanding the periodic table, elements beyond known limits may form in high gravity conditions, such as neutron stars, where new equilibrium states arise. Stabilizing superheavy elements. By engineering specific gravitational environments, we might stabilize superheavy elements, significantly extending the periodic table. Conclusion. The application of relative gravity and relative equilibrium reshapes our understanding of atomic and particle theory. By reframing particles as radiative gravitational entities, this model extends the periodic table, provides insights into hypothetical matter, and unifies galactic and atomic dynamics. This innovative approach hints at profound symmetries within the laws of nature, connecting the vast cosmos with the microcosm of particles.
Essay Addenda on the Evolution of the Particle and a Model for Hypothetical Matter by Ryan Carl Daily Draft Roman 3/126 2025. Regarding the scientific method and theory, a model that is intended as a means is just as legitimate as another when achieving the same ends, whether it is based on hypothesis or speculation. Some things are simply not testable, but yet our intuition leads us eventually to the means of their discovery. We as humans cannot be all-seeing, but yet can have a glimpse of what we believe as a truth. The paradigms we forge generally lead us to the ends we seek. Cookbook for the Universe. This paper's intent is in demonstrating a concrete application of the theory of relative gravity. It applies RG with respect to current atomic theory, particle physics, solids, liquid and gases, kinetic theory of matter, superstring theory, quantum gravity, quantum field theory, cosmology, and particle phenomenology. RG can be considered observations or interpretations of the mechanics of nature, and which were crafted in the form of abstract extensions of current scientific laws and accepted theory. The paper consists of two main areas of focus. These are in looking at the atomic particle in terms of an, and in proposing its, evolutionary process as a generic or fundamental manifold, and B, applying this conceptually to the known elements through a model on hypothetical matter. Both areas can be considered separate within their own scope, but which have a shared focus. There are an extensive number of, and subsequent derivatives of theory on particles already. They are all well accepted by the physics community, such in the context of particle physics, the kinetic theory of matter, solids, liquid and gases, superstring theory, quantum gravity, quantum field theory, cosmology, and particle phenomenology. Yet wave-particle duality can have bias in its own interpretation, starting with Steven Weinberg, Paul Dirac, Werner Heisenberg, Poyle, Hahn, Aufbau, and many other of its pioneers in scientific theory. For the known elements, pioneers like Hennig Brand, Johann Dobryner, Aibi Geyer de Chancourtois, John Newland, Dmitry Mendeleev, and Glenn Seaborg can be considered the founding fathers of the periodic table of the elements, or PT. Given actually an extensive history of known as well as unknown contributors to theory, it is perfectly within reason to assume that the foundations of science in of itself will never be complete. RGS basic theory is considered object-oriented. In this manner, theory as abstract principles can be realized in concrete examples through their polymorphism. In this manner, RGS theory intends a normalized framework which adopts symmetry for scientific observations. Based on RGS framework, this paper S theory on particle evolution assumes to resolve bias S between well-founded views for string theory, quantum mechanics, and relativity. This is by offering extensions on their perspectives of the same thing. That is, the basis behind the very nature of the universe. The paper's intent is not to further prove any one of these followings as already assuming their legitimacy through a sustainable history. This applies as well to the value of the PD and how this paper proposes it by Ryan Carl Daily 1. ACA, Essay on Relative Gravity to describe the mechanics of the universe, hypothetical model for calculating atomic weights and electron counts. And that is not Muller-based. Basically, the paper simply leverages others' work through interpretation based on RGS theory. For science, a more clearer explanation of phenomenon is always due. This paper is intended to lend in a sustainable direction of theory for its goal. Every truth passes through three stages before it is recognized. In the first, it is ridiculed. In the second, it is opposed. In the third, it is regarded as self-evident. Arthur Schopenhauer. Cookbook for the Universe. I preface. This paper introduces a practical and concrete application of the theory of relative gravity RG, a transformative framework that redefines our understanding of the universe by integrating classical mechanics, relativity, quantum mechanics, and string theory into a cohesive model. At its core, RG offers a unifying principle, relative force, which serves as the foundation for understanding the interconnectedness of forces, particles, and cosmic systems across all scales of existence. While RG encompasses a broad theoretical scope, this paper focuses specifically on one of its applications, the recalibration of atomic structures and the periodic table of elements (PT). RG provides a dynamic lens for examining particle evolution, symmetry, and resonance, allowing for deeper insights into atomic theory. By proposing novel methods for calculating atomic weights and electron counts, RG extends its principles into practical applications within particle theory and beyond. Relative gravity builds on the work of pioneering physicists and scientists who laid the groundwork for our current understanding of atomic and quantum theory. Figures such as Steven Weinberg, Werner Heisenberg, Paul Dirac, and Dmitry Mendeleev contributed invaluable insights into the mechanics of nature, atomic evolution, and the periodic table of elements. This paper seeks not to replace these foundational theories, but to extend them by addressing unresolved questions and integrating their principles into a cohesive, scalable framework. Central to RG is the concept of symmetry as a dynamic, iterative process. Symmetry is not merely a static property, but a fundamental principle that governs the evolution of particles and fields. This framework embraces the idea that particles, galaxies, and even universes can be modeled as evolving manifolds, where symmetry is conserved across dimensions of time and space. By Orion Carl Daly II. Cookbook for the Universe, Scope and Approach. This work explores the mechanics of RG through the following. Relative force, the foundation of RG, representing the common property shared by all fundamental forces. Particle evolution. Particles are modeled as evolving manifolds that iterate through dimensions of time and space, conserving symmetry and relative force. The periodic table of elements. RG offers a method for recalibrating atomic weights and electron counts based on torque constants and resonance frequencies. This approach emphasizes the periodicity and harmonic relationships within the atomic mass spectrum (AMS), uncovering new patterns and opportunities for discovery. By using RG as a lens, this paper revisits the Big Bang and its subsequent evolution, proposing that the universe can be seen as a dynamic manifold of alternating currents. This perspective reframes phenomena such as the unification of the four fundamental forces and the emergence of the atomic elements as processes governed by symmetry and relative force. Novel contributions. The primary contributions of this paper include a unifying framework integrating diverse scientific paradigms into relative gravity, a recalibrated atomic mass spectrum that identifies harmonic periodicity and resolves biases in traditional AMU calculations, a dynamic model of manifold evolution that connects atomic particles, forces, and time as interrelated phenomena. As Schopenhauer noted, every truth passes through three stages before it is recognized. First, it is ridiculed. Second, it is opposed. And third, it is regarded as self-evident. This work challenges conventional boundaries, offering a new way of seeing the universe not as a collection of isolated phenomena, but as a symphony of forces, harmonics, and evolving systems. The sections that follow build on this foundation, presenting the mathematical, conceptual, and practical frameworks for applying RG to particle evolution, atomic modeling, and beyond. This work is both a continuation of humanity's scientific journey and a leap toward new horizons of understanding. By Orion Carl Daly III. Aka, Essay on Relative Gravity to Describe the Mechanics of the Universe Roman II Summary. For relative gravity, particles are considered to have opposite charges and consist of harmonics of vectors with wavelengths that are subject to distortion. This is possible in RG without contradicting the views of Bohr, Pauli, Aufbau, and others. Bodies are cumulative with respect to others. Relative gravity is viewed as their fundamental relationship through superposition between bodies, and in their spatial time, their relationship is considered skewable. From the standpoint of RG, particles, which are considered to be the constituents of matter itself, are viewed somewhat similarly to but distinctly from the accepted atomic theory. For string theories or other, seen as a current, if one were to coalesce with instances of itself or others in an event of superposition, a manifold in a spatial time can be expressed as a spatial manifold. In fact, Our early universe can be seen in a like way if observing its point XYZ as a composite, like the way we view early universe pictures from Hubble, or constellations from Earth. RG views a fundamental manifold in terms of its vectors. In fact, for RG, even strings from string theory are considered forms of vectors. For RG, dimension and time are allowed to have infinite bounds by default. For RG, dimension and time are allowed to have infinite bounds by default. On the surface, this somewhat contradicts the basis for the Big Bang. Cookbook for the Universe, for example, it removes the mystery of where, somehow, a singularity containing everything necessary to create a universe in an inertial frame of reference exists with an absence of space and time. Steven Weinberg's first 3 minutes of the Big Bang describes consequent stages of evolution occurring as a process of mystical causality. Source C. Resonance CRFQ equals amplitude velocity. For RG, there is the dimension of time. This allows a singularity to be simply another isolated system consisting of some manifold Z. As a composite, it further is considered to explain superposition with vectors xy as being earlier incidences of Z. In the context of its existence as an inertial frame of reference, it is expressed as an ideal field of uniform relative force, or IRF. RG's relative force, or F, is seen as the relationship of alternating currents for any number of vectors that make up a manifold Z. Consequently, the property of force must first be thought of as relative and hierarchical in context. RG's paradigm allows latitude for theory. Being relative, an event of force can be causal or acausal in origin, that is, in having the properties of a reference frame. It can be random, but also have properties of symmetry as a relative force with other reference frames. In a more a priori state, and to suit an event of superposition in some spatial time, torque can be construed as a fundamental property shared between fundamental vectors x, y, and z, which can explain the basis of a manifold as a relative force Rf. Torque can be considered an alternating current of a manifold's axis. How to derive vectors for a field in a spatial time defined as a uniform relative force, IRF. Intended as a matter of its axis S torque, a three-dimensional manifold can be defined geometrically within an area described as 4πr. That is, for particle theory here, the same principles are to apply to its most fundamental expression before building an atom, or in further assuming atomic bonding to yield molecules. This is further to be consistent with the linear nature of the atomic weight spectrum for the periodic table of the elements B, which is demonstrated later in the model on hypothetical matter. Each element can actually be derived as a model of IRF. In terms of atomic weight, progressions based on levels of torque can be marked as some form of a consequent evolution. That is, from a previous expression of existence can be in a causal, yet be derived in a natural order. Construed here for the t-coordinates for a spatial expression, x plus y plus z as dimension x, y, z, are seen to express unique spectrum S as even other spectrum S. By Orion Carl Daly 6. Cookbook for the Universe, Roman 4, a model for the fundamental particle. As all bodies in RG are first viewed as manifolds, which have a basis for volition based on alternating currents of one form or another. Fundamental particle evolution is proposed based on the assumption of a spatial manifold. Seen as a virtual vector, a resonance is thought to coincide with itself. As spatial time, this is considered through a number of hypothetical steps in its evolution. Each step is considered to have a unique realm of context for maintaining the laws of conservation in its properties. As a syncopated superposition of vectors x, y, z to n, as an event, is thought of as some coincident order in its own unique spatial time. For example, like the consequent evolution of an inertial frame of reference. Energy, such as measured in joules, can be considered in a temporary state or quiescence in spatial time of some natural order. By Orion Carl Daly 1. Aka, Essay on Relative Gravity to describe the mechanics of the universe, theoretical steps of particle evolution. For a hypothetical particle as a manifold, the basis is first considered a source C of some alternating current. The manifold is to represent its current as consequent evolution through its resonances as vectors ER. Resonance as an expression of relative time. One period of resonance, because reference frame B can exist, that for every period of expression of its existence. There is a period F as a spatial time for the existence of B with respect to A. Period of resonance FFF describes the temporal framework within which system B expresses itself relative to A. This periodicity governs the oscillatory interactions between A and B, ensuring that transitions occur within a consistent temporal interval. Spatial time ties these transitions to the system's geometry, linking spatial configurations to temporal behavior. In relative gravity, this concept unifies space and time as interconnected metrics for understanding resonance, providing a coherent framework for measuring the evolution of systems across states. 2. Spectrum of resonance. Various expressions of relative gravity can therefore be expressed during the transitions from a state to B, or within the spectrum of resonance that occurs as expressed by B with respect to A. The spectrum of resonance captures the dynamic range of oscillatory states that a system explores during transitions between A and B. Each state within the spectrum represents a unique configuration of energy, force, and time, reflecting how the system evolves while maintaining coherence with its origin. In relative gravity, these transitions encode various expressions of resonance, embodying the interplay between symmetry, inheritance, and adaptation, whether applied to particle moments, manifolds, or fields. The spectrum of resonance provides a unified framework for understanding how systems dynamically reconfigure across state. Free resonance frequency. Consequently, during when B exists as a constant expression of A, the transition between the two known states of A and B can be expressed as the movement of to and fro. An average of ET can be achieved likewise between states A and B via 2 pi infinity T infinity, or in other words, a resonance is expressed by way of the to-fro or a sine wave. Resonance frequency describes the oscillatory behavior of a system as energy transitions between states AA and BBB. When BBB exists as a constant expression of AA, this transition manifests as a symmetric to and fro movement, producing a sine wave that represents the resonance. The average energy to time ratio ET between states can be calculated as 2 pi infinity to infinity, linking the system's periodicity to its energy and time characteristics. This dynamic governs the stability and symmetry of the system, enabling it to maintain coherence during oscillations. Resonance frequency thus forms the foundation for understanding periodic phenomena in relative gravity, from particle transitions to field dynamics, providing a unified framework for energy-time interactions. 4. Resonance period. The phenomenon is inconstant, or as much a constant as the root mean square of that yields B in the first place, and that this is subject to a S conveyance of force through inheritance. This is considered subject to some coincident order, or relative. By Orion Carl Daly 2. Cookbook for the Universe. Time therefore is considered that constant. The resonance period reflects the dynamic oscillatory behavior of a system as it transitions between states. While the phenomenon appears inconstant due to oscillations, it is governed by a measurable constant, the root mean square RMS of AA, which provides the average energy transferred to BBB. This resonance is sustained through IAS conveyance of force via inheritance, ensuring symmetry and coherence between the systems. This process is further governed by a coincident order, where the alignment of forces maintains stability during transitions. Relative time, serving as a constant reference frame, ensures that oscillatory dynamics remain predictable and measurable, enabling the system to evolve harmoniously within the RG framework. 5. Resonance inheritance. Based on the coincident order of force, B can be established based on A, and through the inheritance of properties. Like A can have its own coincident relationship with other forces as from another entity of FTF like A. Resonance inheritance describes how systems evolve through the transfer of properties from one state to another, guided by the coincident order of force. System B inherits fundamental characteristics from A, such as resonance frequency and energy distribution, while forming new relationships with external forces FTF. This iterative process ensures that symmetry and coherence are preserved across transitions. Through this framework, relative gravity explains how systems maintain stability while adapting to new spatial and temporal contexts, enabling the evolution of particle moments, atomic structures, and even large-scale fields. 6. Resilience at known states can infer spectra for ET as a single entity. Resilience at known states reflects a system's ability to maintain coherence and stability during transitions. Within relative gravity, this resilience is expressed through the ET spectra, unifying energy and time distributions into a single coherent framework. This highlights how particle moments retain symmetry and structure despite oscillatory dynamics, enabling their evolution into higher-order systems. By integrating resilience with the notion of superposition and polymorphism, RG provides a robust model for understanding the temporal and energetic consistency observed across particle states. 7. Resonance mean and resonance spread. Area mean energy equals frequency amplitude describes how energy oscillates within a spatial domain. For a particle moment, the area corresponds to the spatial extent of its manifold, while mean energy represents the average energy distributed across this region. Frequency captures the oscillatory behavior of the particle's resonance, and amplitude measures the peak intensity of these oscillations. Together, these properties govern how energy transitions between states of resonance and how a particle evolves through subsequent configurations. For instance, a contraction in the area of the manifold concentrates energy, amplifying oscillations and increasing stability, while expansion diffuses energy, reducing oscillatory intensity, and therefore can be construed to express the frequency and amplitude of a radii. By Orion Carl Daly 3. Aka, Essay on Relative Gravity to describe the mechanics of the universe, a model for particle evolution. As a model, particle evolution is described as seven theoretical steps which follow. They are not intended to be testable here. Instead, as a matter of natural progression, each step, in representing more of a speculation than a hypothesis, assumes its previous step. The particle is referred to as the particle moment PM. It is represented as a manifold Z which itself represents a harmonic of some resonance of ZR. That is, particle moments exist as an isolated system, noted as within a given spatial time as an inertial frame of reference referred to as resonance CR. As within an inertial frame of reference, the manifold demonstrates evolutionary consequences in the step S progression based on the carry forward of properties through polymorphism with respect to a level of permutation. Step 1 in assuming probability. Let there be a current of source C that resonates plus or minus at range ZR such that source C alternates in disposition that is marked by an oscillation T. Consequently, in combination of range ZR, oscillation T defines resonance ZR. Resonance ZR FQ equals amplitude of source C distance. Assumptions of Step 1. On convergence and in the conservation of elementary particle properties. Let Z represent a band in a strata of linear time, existing within the infinite spectrum Z infinity of frequencies FQ. Within this spectrum, changes Z delta coexist infinitely Z delta infinity in convergences, forming a dynamic hierarchy of states. Linear time, expressed as a single dimension, is derived from all time and dimensions, allowing any derivative to cross-reference another. Consequently, vector Z can reference another point in Z to derive X and Y, reflecting the recursive and interconnected nature of Rg. A unique C is defined by the relationship between source C and resonance CR, representing a step in the natural order. This relationship is expressed as an equivalent relative force or ref, composed of amplitude and frequency, that governs the system's dynamic behavior. The probability of a unique C emerging depends on the equivalence of occurrence and the rate of probability, ensuring that systems align with Rg's natural symmetry and order. By Orion Carl Daly 4. Cookbook for the Universe. Step 2 in assuming probability. Let resonance CR parallel as X and Y in terms of a midpoint or virtual Z, and wherein sharing the same alternating phases of ZR plus. Sagittal view of resonance CR. Assumptions of Step 2. This splitting represents the multidimensional nature of ZR where X and Y retain symmetry and alignment through their connection to virtual Z. The behavior of ZR relative to virtual Z follows the inverse square law, indicating that its intensity decreases with distance while maintaining coherence across the system. The combined behavior of ZR, X, and Y represents a relative force encapsulating the oscillatory dynamics and symmetry of the system. This framework highlights how systems evolve through multidimensional interactions while preserving their underlying connections and properties. Step 3 in assuming probability. Let there be a reference of convergence where virtual coincides with other references to the isolated system that are out of phase such that an iteration of can be referenced separately as, and another as, and where both and maintain their own unique expressions of spatial time and dimension as isolated systems. As a vector, resonance is considered a spectrum of spectra that express alternating phases. This relationship is described as where each spectrum exists as part of the isolated system's time and dimensional context. Hence, xtd approximately ytd approximately ztd where 1 approximately n. By Orion Carl Daly 5. Aka, Essay on Relative Gravity to describe the mechanics of the universe. Assumptions of Step 3. 1. Deltas of vectors. For probability, deltas of vectors can be derived based on the number of convergences, described as, in combinations of and with respect to the number of combinations of the of parallel spectra of. 2. Coexistence of spectra. As expressed spectra of manifolds, deltas can coexist within the spectrum of, where expressed spectra can coexist as in convergences. Spectrum S can intersect other spectrum S, which then can yield others. Step 3 can be considered expressions of coincident order for both X and Y uniquely. This is with respect to their relationship with Z. Their states of TD are considered unique as spatial times. Summary of Step 3. The relationship between XTD approximately YTD approximately ZTD in Step 3 reflects a framework where isolated systems maintain unique expressions of spatial time and dimension while remaining interconnected through resonance and symmetry, although these systems operate independently within their inertial frames of reference. They derive their coherence and relationships from a shared origin. 1. Independence. Each system operates as an isolated entity with its own spatial and temporal identity. 2. Shared resonance. The equivalence highlights that while distinct, these systems are harmonically related. 3. Coincident order. Convergences and intersections of spectra establish coincident order, ensuring relational symmetry and coherence among XTD approximately YTD approximately ZTD. 4. Dynamic interactions. Through delta phenomena and harmonic relationships, these systems evolve dynamically, producing emergent behaviors that align with RGS' emphasis on symmetry and conservation. This interconnected isolation is fundamental to understanding how RG models complex systems, where isolated systems retain individuality while interacting symmetrically within a unified framework. Cookbook for the Universe. Step 4 in Assuming Probability. Let there be a state based on the rate of probability where x, y can cross-reference each other with respect to z. Let there be a manifold Z referred to as the particle moment PM that at a minimum consists of the coordinates x, y, and z while during the time of their cross-reference. Assumptions of Step 4. From Step 3, spectrum S are considered to be created by other spectrum S to represent a state of torque range in the cross-reference of x, y, and z. The products of an expressed spectrum are seen to be put in an orderly manner by other spectrum S, which can provide context. Linear time of Z can express the relationship of vectors x and y based on points of convergence. This is where the perception, as in mirrors of itself as an impedance through symmetry, of xy's ES axis is like a manifold in spatial time. Seeing manifold Z as the particle moment represents the sum of x plus y plus z. As a state of torque in spatial time, the sum total force of the PM must equate to net zero. This is in terms of its relative equilibrium between its inner and outer relativity. That is, in order to express a relative time for it to exist in a state of quiescence, for example, like how a soap bubble lasts as well as a solar system. Noted. Deltas of vectors can be derived based on the of convergences, one in combinations of y and y with respect to the number of combinations of the of parallel spectrum S of z. By Orion Carl Daly 7. Aka. Essay on Relative Gravity to describe the mechanics of the universe in consideration of world lines. With respect to the spectra of Z delta, in assuming probability, as points in a line are considered arbitrary, less how they define the line. Between any two space points is an infinite number of points reference and or for convergence. When points have a context, for example dimension d1, d2, d3, dn, they can still be viewed as arbitrary less the context that they represent. The third dimension is dependent on the second, which is dependent on the first. In other words, from the standpoint of d3, d2 is considered equivalent to d1 from the standpoint of d2. That is, the third dimension requires the second, which requires the first. What differentiates d2 is with respect to d1 and d3. And within the line between d1 to d3, the points can be represented as d1, d infinity, d2, d infinity, d3, dn. Thus d1 as being any part of d infinity can be related to d3 as also being any part of d infinity without the context of d2. Consider if viewing a cube, one does not have to view a plane in the cube in order to view a line that makes up one its edges. But in order to view a cube it is a matter of context represented as d1, d2, and d3. By Orion Carl Daly 8. Cookbook for the Universe. Summary of Step 4. Step 4 builds on the dynamic relationships between x, y, and z, introducing the concept of the particle moment PM. This manifold represents a state of equilibrium where the sum of forces acting across x, y, and Z is balanced within spatial time T and dimension D. Key points include: A. Cross-referencing. X and Y maintain unique isolated systems while referencing Z, establishing a relational symmetry that sustains order in the manifold. B. Manifold is equilibrium. The particle moment PM expresses the sum of X, Y, and Z, ensuring quiescence through relative equilibrium between inner and outer forces. This mirrors natural systems, like the stability of bubbles or celestial mechanics. C. Dimensional context. Dimensional dependencies highlight the interrelation between dimensions, e.g., D1, D2, D3, where higher dimensions rely on the preceding ones for context but remain distinct as isolated entities. D. World lines and continuity. Within the manifold, an infinite number of reference points world lines allows for continuity and convergence, ensuring harmonic transitions between states. E. Emergence of structure. Through cross-referencing, new structures and spectra emerge from existing relationships, showcasing how spectra within Z delta give rise to complex patterns. By Orion Carl Daly 9. Aka, Essay on Relative Gravity to Describe the Mechanics of the Universe. Step 5. The differentiation of a particle. For RG dimension XY's, E represents a geometrical expression for a spatial time. Step 5. The differentiation of a particle. For RG dimension XY's, E represents a geometrical expression for a spatial time. It is to exist as an abstract body. As a reference frame, it is referred to as a realm of context TD. This is so to be able to represent manifolds of ETZ. For spatial manifolds, linear time Z can consist of a matrix of an infinite number of world lines. Further, each may be considered infinite in range. Source: T0.G, static.com. In probability, an infinite number of world lines as threads upon convergence, with respect to a reference between them, is considered capable of providing an expression of XYZ, and where geometrical form is a matter of perspective as a dimension of XYZ in a state of quiescence. As Step 5 as foundation, Steps 1-4 address hypothetical stages in the transformation of energy. This is in terms of consequent evolution S of a natural order for source C with respect to its world line or thread as resonance CR. In review, Steps 1-4 references linear time, and were expressed as a derivative of other references to time. In each step 1-4, energy is expressed as a relative force that is in a specific step S context. Energy can be considered transformed with respect to a reference to time between steps. The mean of virtual Z as a scalar for the steps can be viewed as a relative force that expresses consequent evolution from source C to manifold Z. For probability, natural order, by default, is viewed in how one category of existence, or how a delta phenomenon, expresses itself, though symmetry with other parts of a greater one that is expressed as delta equals 1 approximately 2 approximately 3 approximately infinity. Time and dimension are considered to be derived within the dimension of time. In RG, the dimension of time is not considered a single dimension, but instead consisting of the relationship of infinite time and infinite dimension. By Orion Carl Daly 10. Cookbook for the Universe. Force is a continuum. As the relationship of infinite time and infinite dimension is considered perpetual, the unification of force is seen as a normalized relative force, or those properties which are shared between forces. From relative gravity, any expression in polymorphism of force, when viewed as a singularity or otherwise, is considered to be derived within its own spatial time from other things. As a spatial expression of coincident order, it is considered a derivative from the relationship of other reference frames and their spatial times. In Step 3, for a spatial expression of coincident order, harmonics are themselves considered spatial. As is the case for radiation, coordinates for a spatial expression x plus y plus z are thought to be able to express unique spectrum S in terms of other spectrum S. When considering an inheritance factor for a basis of polymorphism, in Step 4, manifold Z, consisting of the convergences of x and y with respect to virtual Z, is subject to the relative force in Step 1 of source C with respect to resonance CR. The expression in polymorphism is seen like a synthesis of relative forces within an area of the coincident order that is in a state of quiescence. This could be construed as an atomic mass spectrum when applied to the construction of an atom. Derivatives of dimension XYZ. In step 5, the probability of convergence of xyz is based on derivatives of phases enabling a dimension xyz. Disposition is represented as valences. Consider this compared to Newton's view. Given valences, let there be multiple frames of reference for particles based on the phases of x, y, and z that are uniquely based on their inheritance factor. 3x plus yz plus 4x plus yz 7x yz plus 8x yz. Let coordinates x, y, and z represent opposite states plus of unique phase for resonant zr at amplitude source z. Hence the characteristics of xyz as a particle are subject to the disposition of phase plus with respect to x, y, and z as valences. Let the state of particles relative to each other be represented as more positive, less negative, and more negative with respect to their frame of reference. Note, each reference frame with respect to another provides a basis for a spatial time between the two. The probability is considered based on the total number of relations. Total number 1. By Orion Carl Daly 11. Aka, Essay on Relative Gravity to describe the mechanics of the universe. Assumptions of step 5. The particle can be considered as in its inertial frame of reference. Its event can occur perpetually based on coordinates x, y, and z. In each case, for Rg, there is a relative equilibrium in a spatial manifold between perpetually related forces of x, y, and z. When viewed as dimension x, y, z, the abstract particle demonstrates poles. As valences, this also simplifies the notion of orientation and alignment of an axis. In other words, even for an atom, see as dimension x, y, z, the state of relative equilibrium can be based on the sum of attracting and repelling forces. That is, in a case of x plus y plus z plus an x, y, z, if to represent repelling forces, then relative equilibrium is thought to be expressed as other forces around the event that counterbalance it. In all other cases of dimension x, y, z, if to represent attracting forces, relative equilibrium can be based on a multiple to 1 coordinates, or a range of relative force from plus 2. With respect to external relative forces around the event, ranges plus 2 are viewed as a unique band in a spectrum of relative forces. Let forces x, y, and z describe a field, the particle moment pm, as E4 pi, where it can be considered alternating in phase based on the phases of x, y, and z in points of quiescence. As points of quiescence, a particle moment between relative forces enable an expression of time. Such expressions can be derived in wavelengths as is demonstrated in a transference cycle such as between heat and cold. Consequently, as a unit of a vector, time can be established through wavelengths. Where expressed spectrum S can coexist as derivatives of infinity delta infinity. Let there be a periodic expression of the particle moment that represents both states plus a phase where an expression of the particle can range in charge from more positive to more negative. With respect to particles of similar definition in convergences of z infinity bands within the spectrum of z delta. In retrospect, for a particle moment, there is no smallest nor largest, and charge can range in probability. For amplitude and frequency based on 8 dimensions of dimension x, y, z, total number of possible particles, 2 derived particle types. By Orion Carl Daly 12. Cookbook for the Universe. Manifolds as isolated systems in step 5. In Rg, as time and dimension are considered derived from other times and dimensions, isolated systems, when demonstrating an inheritance of properties, can be thought as hierarchical where envisioned. For a spectrum of unique harmonics of an isolated system, such as in the atomic mass spectrum, can define a manifold Z. Inherent uniform relative force as dimension xy's, E4 pi can be construed as sinusoidal spirals in net effect. Earth equals 4 pi or 2 square root sigma f. Noted, in Rg, harmonics are viewed as a cyclic expression based on frequency and amplitude. As in the case of the atomic mass spectrum, spatial harmonics are considered the sum of all forces ample Cn for the given spatial expression of radii r. Step 5 is key points. A. Transformation of energy. Steps 1-4 provide the foundation for energy transformation, where energy evolves naturally through resonances e.g. Zr and harmonics. The differentiation into particles is seen as a continuation of this evolution. By Orion Carl Daly 13. Aka, Essay on Relative Gravity to describe the mechanics of the universe. B. Probability and symmetry. The probability of convergence between x, y, and z is based on derivatives of phases, enabling distinct particle identities. This is expressed through valences, which align with Rg's emphasis on symmetry and relational harmony. C. Manifold Z and relative force. Manifold Z, as the particle moment PM, encapsulates the relative forces acting between X, Y, and Z, ensuring a state of relative equilibrium. These forces include attracting and repelling components, balanced to achieve stability. D. Harmonics and spatial expression. Harmonics in RG are cyclic and derive from the interaction of frequency and amplitude. These are foundational for understanding phenomena like atomic mass spectra, where spatial harmonics represent cumulative forces. E. Infinite dimensions and time. The dimension XYZ is derived from the perpetual relationship between infinite time and infinite dimensions. This perspective aligns with RGS' view that time and dimension are not static, but dynamic and relational. F. Hierarchy of isolated systems. Isolated systems inherit properties from previous states, creating a hierarchical structure. This inheritance facilitates polymorphism, allowing isolated systems to adapt and evolve while maintaining their coherence. Graham's particle moment and quiescence. The PM represents a state of quiescence, where internal and external relative forces balance. This is critical for the stable existence of particles in spatial time, analogous to phenomena like atomic or solar system stability. H. Sinusoidal spirals and polymorphism. The concept of sinusoidal spirals emerges as a visual representation of harmonic relationships, where uniform relative force is expressed across dimensions. This cyclical nature is essential to understanding how particles interact and evolve. Retrospective. Step 5 encapsulates RGS' holistic view of particles as dynamic, interconnected systems. By framing particle differentiation as a result of resonance, symmetry, and harmonics, RG bridges micro and macro scales, providing a unified model that encompasses atomic-level phenomena and cosmic structures. By Orion Carl Daly 14. Cookbook for the Universe Step 6, Particle Momentum and Conservation of Energy. In this section, we delve deeper into the concept of particle moment PM as an extension of the manifold and its relationship to torque and conservation of energy. Building on previous steps, this section refines our understanding of PM as a fundamental state within a unified framework. For Step 6, additional frames of reference are considered inherited from virtual Z and resonance ZR. Each PM emerges from inherited properties of virtual Z and resonance ZR within the manifold. These inherited properties establish the foundation for the convergence of Z infinity bands, producing a spectrum within Z delta that adheres to RGS framework. The cumulative sum of frames of reference is based on the convergence of Z infinity bands within the spectrum of Z delta, but are also seen as in combinations of the 8 relational states in relative equilibrium that were noted in Step 5. Here, the relationship of relative distance with respect to relative polarity is reflected in the combination of valences. The particle moment. The origin S of a manifold are considered first, a causal, and second, as a fundamental particle, intended to seemingly parallel in properties, or in a symmetrical in manner with others. This is where variances can be viewed as minimal, significant, none, or perceived in expression. The particle, according to Step 5, based on the property of inheritance, can be represented as Step 4's manifold. Properties of torque are to be represented in at least 8 relational states of valences. Manifold Z. By Orion Carl Daly 15. Aka, Essay on Relative Gravity to describe the mechanics of the universe. Earth equals 4 pi or 2 square root sigma f. The PM is envisioned as a manifold that expresses the cumulative properties of torque, vectors, and force. It achieves relative equilibrium between internal and external forces, ensuring its temporal stability. PM serves as a state of symmetry, demonstrating coincident order among its relational states within spatial time. As a manifold assumed, the Earth can express a complete harmonic spectrum through dispersion of 8 relational states of dimension XYs in the relationship of virtual Z and resonance Z. The Earth with a total area force of 4 pi square root sigma RF represents an amplitude of source C and a resonant frequency thought of as resonance CR, which for the period of relative time can be envisioned as a moment of convergence of dimension XYZ. As a particle, a manifold is vectors XYs, they are imagined as rotating where expressing a relative force envisioned like a torque. This is based on the 8 relational states in periodic occurrence. Hence the particle, if viewed as a field, can be described as. By Orion Carl Daly 16. Cookbook for the Universe. Earth of dimension XYs, E4 pi representing a uniform relative force, has a field surface that is subject to 8 relational states of dimension xyz. This is thought to provide a tunnel effect. For example, the probability that a particle of given potential energy can penetrate a finite barrier of higher potential. Speculated, the behavior of the particle moment PM is based on the inherent torque within the axis of a manifold. This is equivalent to holding an object in orbit around an axis at a given distance within a three-dimensional field that can be interpreted as TQ for torque. The particle moment PM is intended to express the sum of coincidences of vectors which are in phase with another, i.e., a coincident order derived from a progression of natural order in what can be termed a consequent evolution in a state of order. The moment refers to the period of observation, relative or periodic time t, of the existence for the expression only of the particle in question. As a charged field, the relational states can be considered demodulated and modulated depending on point of reference. This is where angular momentum is assumed to remain constant in both magnitude and direction. Summary of Step 6. Particle momentum and conservation of energy. Step 6 explores the intricate dynamics of particle momentum and how energy conservation principles are applied within the framework of relative gravity. He. By Orion Carl Daly, 17. Aka. Essay on Relative Gravity to describe the mechanics of the universe. Takeaways include: A. Inheritance of frames of reference. Particle momentum builds upon prior steps, inheriting frames of reference from virtual Z and resonance CR. The cumulative relationships form the spectrum of Z delta, aligning with 8 relational states of relative equilibrium derived in Step 5. B. Concept of the particle moment PM. The particle moment PM is defined as the manifold S expression of coincident vectors in phase with one another. It represents a state of order where torque and angular momentum maintain equilibrium. C. Role of uniform relative force Earth. The Earth expresses the harmonic dispersion of forces across 8 relational states of xyz, visualized geometrically as a rotating manifold. This provides a field capable of phenomena like the tunnel effect, where particles penetrate potential barriers. D. Interdependence of relational states. Relational states xyz oscillate within a charged field, modulated by their interaction points. Angular momentum is preserved, ensuring symmetry and consistency across temporal observations. E. Physical interpretation. The torque curve within the manifold reflects the inherent properties of particles, connecting energy conservation to the coincident evolution of vectors. This model emphasizes how a particle exists within its field, adapting to both internal and external influences while maintaining symmetry in dynamic contexts. Step 6 establishes the foundational behaviors of particles in motion, linking their properties to torque, energy conservation, and harmonic dispersion, all framed within the dynamic relationships of relative gravity. Step 7. A new frame of reference and the conservation of natural symmetries. By Orion Carl Daly, 18. Cookbook for the Universe. The laws of physics should be the same regardless of changes of position or of orientation in space. Relative gravity's law Roman 4 intends that consequent evolution can be expressed in terms of the equivalence in result where, in the case of the manifold, points of quiescence enable an expression of time and dimension. Consequent evolution of a field and its geometric progression. The mean of virtual Z can be viewed as a relative force that expresses consequent evolution from source Z to manifold Z. The relationship of the vectors afford other coincident moments of convergence. Thought: when given consequent evolution, other particle moments can be expressed from the original field in Step 6. Represented as a geometric progression, manifold Z as Earth equals 4 pi r square root sigma F can be extended in field strength, and therefore in area and density. Following is an example of the delta plus 1 in the consequent evolution of the particle moment into new particle moments. By Orion Carl Daly, 19. Aka. Essay on Relative Gravity to describe the mechanics of the universe. For example, delta plus 1, if to occur in the consequent evolution of a particle moment, should derive new particle moments. Concluded, the area and density of a manifold are proportional to its axis torque. As a natural form of regulation, the torque curve is thought to share symmetry based on the principles of the inverse square law. For regulating the tunnel effect, inherent is the probability that a particle of given potential energy can penetrate a finite barrier of a higher potential. Torque curve is thought to become skewed in a logarithmic manner based on generations of progressions. Eventually, further evolutions require greater thresholds for torque to meet. Conservation of symmetry. Based on hypothetical matter calculations later for IMU, electron counts and placement in the PE. Conservation of symmetry is considered maintained in the consequent evolution of a manifold into other particle moments. This is considered consistent with the observation that energy cannot be created nor destroyed, but transformed, and where entropy is seen for utility. Based on the calculations using a torque constant, IMU and electron count increase is consistent in manner with existing assignments in the PD. Thought here, particles can be derived from other particles of like properties. Seeing each assignment in the PD represents an expression of a source C and resonance CR. As in the atomic mass spectrum, the assignment is expressed in the coincident moments of convergence of the evolved field dimension XYZ that can be defined as an IMU and electron count. Assumed, the extent of the consequent evolution of particle moments is considered to be based on the relative force from a derived origin. This is where RGS relative equilibrium should be thought of as complementary forces around the event that counterbalances it like a factor of impedance. In all other cases of dimension XYZ, if to represent attracting forces, relative equilibrium can be based on a multiple to 1 coordinates where range of relative force is from plus to infinity. With respect to external relative forces around the event, ranges plus to are viewed as a unique band in a spectrum of relative forces. Here, dark matter, if thought of as absolute space, can be construed as a counterforce with respect to any body in space. Summary of Step 7. A new frame of reference and the conservation of natural symmetries. By Orion Carl Daly 20. Cookbook for the Universe. Step 7 introduces a pivotal perspective in relative gravity, the establishment of a new frame of reference that upholds the conservation of natural symmetries. This step explores how fields evolve dynamically yet remain consistent with fundamental laws of physics. A. Equivalence in results. Relative gravity's law Roman 4 asserts that physical laws maintain their form regardless of position or orientation changes in space. The equivalence in results reinforces symmetry and conservation principles across reference frames. B. Points of quiescence. These represent states where the manifold stabilizes, allowing the emergence of time and dimension. Quiescent points serve as the anchors for defining spatial and temporal frameworks within evolving fields. C. Geometric progression in field evolution. Consequent evolution of the manifold is described through the relative force derived from the mean of virtual Z. The relationships between source Z and manifold Z trace a geometric progression, highlighting the field S transformation over time and space. D. Implications for frames of reference. Each new frame of reference encapsulates the system S invariance under transformation, ensuring conservation of energy and symmetry. These frames expand the understanding of how isolated systems interact while maintaining coherence within their broader field. Step 7 concludes the progressive framework by demonstrating how relative gravity integrates symmetry, conservation, and dynamic evolution into a unified description of natural phenomena. The geometric rendering reinforces the concept of interconnected systems evolving harmoniously, adhering to fundamental principles of physics. By Orion Carl Daly 21. Aka, Essay on Relative Gravity to Describe the Mechanics of the Universe. V. The particle moment PM Scientific Theory and Laws. The PMS characteristics are based on relative gravity's laws. They themselves are considered liberal extensions of accepted scientific law. Based on RGS law Roman 4, the model for a fundamental particle-less moment is seen plausible and probable. For plausibility of a causal origins, RGS law Roman 4 points out that a thread A and B, as wavelength times, might or might not exist in a state where they originally derived to C equals BD as points of a new wavelength. In other words, in terms of randomness, there could always be another group of a B. C and D that can derive the same wavelength or one similar to some other instances of frequencies AC equals BD. Here the Heisenberg uncertainty principle by Orion Carl Daly 22. Cookbook for the Universe is observed. The particle moment PM is intended to express the sum of vectors in coincidence with respect to their valences. The moment refers to the relative or periodic time t of the existence for the expression of the particle in question. For that moment, they are considered in phase with each other. The atomic particle. The order of electron occupancy for science is considered to be based on a stable arrangement. By Orion Carl Daly 23. Aka, Essay on Relative Gravity to describe the mechanics of the universe. In general, if we were to view the PM in the context of Louis Victor de Broglie's wave mechanics, where the wavelength of an object in motion is inversely proportional to its momentum p, the symmetrical expression of consequent evolution can then further assume compliance with Hund's rule, the Aufbau principle, the Pauli exclusion principle, and the laws of uncertainty. Consistent with Aufbau's principle that lower energy orbitals fill first, the PM must occur in expression TQ plus 1 before it can occur in TQ plus 2. For the Pauli exclusion principle, an orbital is thought to hold only 2 electrons with opposite spins T. Interpreted, the PM can occur at opposite points representing equal distant radii from the origin or nucleus. Being mirrored in its expression in opposite state, a given reflection can represent an impedance. For Hund's rule, if 2 or more degenerate orbitals are available, 1 electron goes in each until all are half full. For the PM, consequent evolution occurs as TQ plus 1, TQ plus 2, and TQ plus n. TQ plus 1 is assumed to still exist when PMS occur at level TQ plus n. By Orion Carl Daly 24. Cookbook for the Universe. For the Heisenberg uncertainty, the relative standard uncertainty y of a measurement result y is defined by y equals uyy, where y is not equal to 0. Calculating that the probability of an event is limited by the precision of a measurement for the PM. As seen in the Copenhagen quantum mechanics interpretation, the act of measurement causes the set of probabilities to immediately and randomly assume only one of the possible values. For determinism uncertainty, given dimension xyz, multiple particles may combine in relationship based on their number of combinations. 2 particles can have 16 relational states, and 64 for 8 and so on. The particle moment PM. The particle moment PM is a fundamental concept in relative gravity, representing the intersection of time, dimension, and force. As a theoretical construct, the PM serves as the basis for understanding how particles evolve, interact, and maintain relative equilibrium within isolated systems. Definition and function. The PM is defined as a manifold of dimension xyz that encapsulates a specific configuration of energy and force at a given time. It is expressed as a dynamic system balancing internal and external forces, ensuring stability in the framework of relative gravity. Properties of the particle moment. Torque and angular momentum. The PM demonstrates torque based on its rotational axis, ensuring consistent angular momentum in both magnitude and direction. Symmetry and conservation. The PM adheres to natural symmetries, reflecting the conservation of energy and alignment with relative gravity as principles. Dynamic evolution. PMs evolve through interactions with other manifolds, maintaining quiescence through relative equilibrium between internal and external forces. PM in context. The PM is visualized as a charged field capable of transitioning between modulated and demodulated states depending on its relational frame of reference. Its behavior aligns with harmonic principles, exhibiting resonance frequencies and amplitudes that regulate its interactions with surrounding fields. Particle autonomy. Given the conservation of symmetry, particle relationships can be viewed as both time and dimension, where having an autonomy in spatial time with respect to themselves. By Orion Carl Daly 25. Aka, Essay on Relative Gravity to describe the mechanics of the universe. Particles are thought to have an autonomy with respect to their relationship. In this way, the PM is seen consistent with 4 laws of relative gravity. Law Roman II Observation 1.4 Autonomy is viewed as an entity-S relationship with another such that there are quanta of probabilities and combinations represented. Note before, as much as there is uniqueness, there could always be another group of wavelengths of B, C and D that can derive the same wavelength or reference frame as others. In other words, frequencies are derived from others. Autonomy can imply randomness. RGS 4 laws are based on the delta phenomenon, where in principles Roman 3 and Roman 4, uniqueness is addressed as property inheritance. Principle Roman 3, the delta phenomenon applies to an entity or a family of entities such that each may be a unique personification, yet be part of the same delta phenomenon. Principle Roman 4, consequently, the delta phenomenon, although unique, can parallel itself. Principle IV.A. Hence, a point of reference can be established from one category of existence to another through the relationship of uniqueness expressed through symmetry. Intended, an entity which has reached a point, thought as a hysteresis in its own definition, like in the case of the planets in our solar system. As an individual might also have a greater superposition with another. Simultaneously, it is considered in superposition with respect to time and space with still others. Law I. The nature of force is subject to the disposition of the entities, and subject to the inheritance factor of linear time. I and RG, dimension and time, are relative. There is no such notion as to the largest or smallest particle. As isolated systems, what is observed is made up of even smaller ones. Currents can be composed of particles which can be made up of still other currents. Electrons are considered to remain constant in size based on an amplitude and reference to a frequency TF. Particles can be thought to serve as a building block for other particles that make up a fabric. This fabric is based on inheritance where relative in spatial time is a reference to other TFS. The particle moment PM is thought to occur during the period of a spatial time. Seen, unique vectors are shared with 2 or more fields from a spatial manifold where having a reference to an origin as dimension xyz. Vectors xet plus yet plus cet and assuming net are variable allowing states of valence n. By Orion Carl Daly 26. Cookbook for the Universe. Therefore, disposition with respect to other manifolds. See, the PM is seen as an expression of a spatial manifold. It can be in a state of quiescence of relative equilibrium, while consistent with the principles behind chemical equilibrium where dispositions are constant, xet approximately yet approximately zet. The PM is thought to inherit its own expression of torque TQPM. This can be based on a single manifold or more. The resultant expression of torque for the particle moment can be reasoned as: given that the PM exists in an inertial frame of reference, there is an element of torque assumed where the sum of forces is equivalent to TQPM. Axis TQPM equals fabric field at torque plus fabric field BTQ plus fabric field in TQ. Given a change in disposition, such as an increase in torque by one or more of the spatial fabrics within some coincident order as the axis, the state of the PM can go from TQPM to TQPM plus 1 or plus n. For a change of state from its existing relative equilibrium as an ERF, the PM expresses torque in the context of its own manifold, given in all cases where the PM is in its inertial frame of reference and in a state of relative equilibrium when subject to coincident order with other manifolds. It can express TQPM plus 1. The reference is relative to other manifolds. In this manner, torque TQ can be thought of as an underlying force that yields particle moments. They in turn have their own axis of necessity TQPM to maintain. This is a product of the original TQ, and in addition can also be from other TQS of other manifolds. Natural order is considered regulated as a relative force diffused through consequent evolution. F. The manifold is considered to express a hysteresis in field strength. This is to be based on unique states or scalars in a range or scalars or a vector of torque. Torque is thought to be consistent within the resonance bandwidth of the field for the period of this state for the coincident order involved. Law Roman II. Between entities in spatial time with respect to a factor of distance, disposition is observed as the attraction-repulsion level exhibited. The classical view of fermions and other subatomic particles are described in science for demonstrating the relationship of matter and antimatter, and how the nature of the strong force is exhibited in the nucleus of an atom, and also how the nucleus can be further made up of quarks, and then how electrons can be positrons, and then how the weak force is exhibited. Allowing similar latitude, based on the dispositions of its fields, the PM is considered to exhibit valences. This is in addition to the relationship that it has with its origin. Chemical bonding and law Roman II of relative gravity. As atomic fields move, disposition can change in state. Entity resonance based on. By Ryan Carl Daly 27. Aka, Essay on Relative Gravity to describe the mechanics of the universe. Valence for a relative time can be theoretically reasoned. For every reference frame A, or a field AFTF, there is a B seen as the resonance of A. Resonance B is therefore from a known start state of A to a stop state of B. Ionic and electron states in atomic elements are expressions of variance in the state within a third reference frame C. Due to its valences, the element can be ionic, atomic, and or plus ionic in state. In chemistry, a covalent bond is thought to result when two atoms share valence. Electrons between them. The ionic bond OC occurs when one atom gains a valence electron from a different atom, forming a negative ion, or anion, and a positive ion, or cation respectively. As oppositely charged, they are attracted to each other. For the metallic bond, believed, valence electrons are free to move about in a piece of metal, and are attracted to the positive cores of copper, thus holding the atoms together. Atomic shells. Variances can be viewed as a valence state of an element with respect to other elements. In chemistry, this is considered the valence electrons in the outer shell of the top energy level. For the PM, as values change, the levels TQ1, TQ2, TQn are thought to rebalance with respect to the origin of TQ, which itself is seeking its ideal state of relative equilibrium as a spatial manifold. Hence the expression of energy levels can occur, where within sub-levels they can also, which in turn can be maintained as orbitals of PMS. Particle synthesis. Consistent with the view on electron orbitals and subatomic particles, due to the nature of a manifold S resonance, the energy state of PMS in different sublevels can overlap. Consistent with the periodic law, it is plausible to consider unique particle types based on the synthesis of electron sublevels and in the nature of the nucleus in the abstraction of yet new expressions of PMS in relative equilibrium. Law Roman III. The average force between entities can be relative to one over another, or equal, based on their equivalence in ET. Averages occur at a relative distance. For Law Roman III, assuming proximity, a state of relative equilibrium can be thought of based on the entities in question. One can be larger than another. This is seen as a property demonstrated in atomic bonds. For example, consider electron equilibrium and the actual relative distance in atomic bonding. Particle moment symmetry in chemical bonding and Law Roman III. Bonding for the particle moment is considered consistent in principle to the. By Ryan Carl Daly 28. Cookbook for the Universe. Characteristics of chemical bonding, less differences noted. Valence electrons can be actively involved in chemical change. They are thought of as electrons in the shell with the highest value of N electrons in the outermost shell of an atom. For example, sodium S ground state electron configuration is 1s, 2s, 2p3s. The 3s electron is the only valence electron in the atom. This is where seeing that valence electrons determine the chemical properties of an atom and are the only electrons that actually participate in chemical bonding. The covalent bond occurs when two manifolds are balanced. The appearance of the PMS is in being shared between them. TQPM1 equals TQPM2 and valence is balanced within the two manifolds. Moreover, the phenomenon of a dida-covalent bond is thought of as the case where a PM has an expression in consequent evolution. That is, it is considered to bond as a spatial manifold that has not expressed a PM in consequent evolution. Ionic bond. Bonding of PMS as manifolds are viewed as an ionic bonding when two or more manifolds require balancing to achieve a new ideal state in consequent evolution. Hence a transfer of TQ is shared such that dimension zab equals za xtx ya I tie z is c plus x bxtx ibi tie z ibis c. Ionic states can be considered a matter of resonance. Reference frame B as the S reflection can be construed as an echo factor of A. B itself is as constant as A, where represents B as fundamental. Reference frame B consequently is a harmonic of A. B is also subject to the disposition of a S parent realm S, consisting of the conveyance of force through inheritance, allows it to have the variance of B as a harmonic. Metallic bonding, seen as flux in the state of a bond. Metals can be viewed to have more resonance than non-metals in a similar manner as alternating current. In fact, the notion of positrons or positive electrons in a sea of negative ones is consistent with our GS view on impedance of matter and surrounding space. Law Roman 4 at a constant distance, the rate of disposition is constant. For a manifold S radii, distance can be expressed as the periodic time where frequency equals amplitude distance. A period is considered to be made up of 2 points. They define a periodic wavelength of the radii for a field in question. This dynamic is generalized so it is applicable regardless of when referring to atomic structures, galactic bodies, and entities between. The manifold is thought to be made up of many radii, which defines the total area as 4 pi, and also the relationship of radii at a given moment. By Orion Carl Daly 29. Aka, Essay on Relative Gravity to describe the mechanics of the universe. Energy applied to the axis XYZ is subject to the number of independent radii, their length, and the total field potential as energy with respect to some torque TQ. Its field as a Earth is represented as a uniform relative force of 4 pi square root sigma Ref. Each radii has inherent a relationship with the whole body of the manifold. The radii represents a component of the total area and therefore can be represented as the diameter of a subfield of the original area. Radii are thought to have the potential to undergo a coincidence of subfield intersections with respect to neighboring radii. TQ. Particle moments can be referred to as area of the subfield intersection. For subfield radii, we can speak of a moment where two or more subfield areas experience an intersection with respect to their origination. The main body is radii. The subfields are subject to coincidence that can be a companion to a constant relation due to the overall strength of a state of TQ. Like valence electrons which bond between elements, the particle moment is seen to represent the rate of disposition of the overall entity in question. Laws of relative gravity in review. Relative gravity introduces a series of scientific laws that govern the interactions of particles, fields, and dimensions within its framework. Law I, symmetry of force. All forces originate from a shared parent property known as relative force Rf. This symmetry ensures that the dynamics of gravity, electromagnetism, strong and weak forces can be unified under a single framework. By Orion Carl Daly 30. Cookbook for the Universe. Law Roman 2, conservation of energy. Energy cannot be created or destroyed but is transformed within the context of time and dimension. The PM serves as the medium through which this transformation occurs, maintaining equilibrium in isolated systems. Law Roman 3, harmonic resonance. Interactions between particles are regulated by harmonic resonance, expressed as oscillations in frequency and amplitude. Resonance frequencies dictate the behavior of PMs within fields, influencing their stability and interactions. Law Roman 4, equivalence in consequent evolution. The progression of systems remains invariant under transformations in position or orientation, maintaining consistency in natural laws. Consequent evolution reflects the dynamic relationships between PMs, manifolds, and reference frames. Conclusion. Section V synthesizes the particle moment, scientific theory, and laws into a unified understanding of the universe's dynamic fabric. The PM serves as the building block for modeling interactions and transformations within relative gravity. By formalizing its laws, relative gravity establishes a robust framework for exploring phenomena across scales, from the quantum to the cosmic. On chemical bonding for Law Roman 4. Atomic radii are assumed to vary depending on an atom in being atomic or in ionic states. This variance for Rg is seen due to a resonance band, and a related mean for the entity in question. Valence bonding assumes proximity for the disposition of energy between two manifolds. Assume the disposition of the PM changes with respect to its state in Rg's relative equilibrium. Therefore, the dispositions of the manifolds in bonding can vary from their sole dispositions. Covalent bonding is seen when TQPM1 equals TQPM2. PM is considered. By Orion Carl Daly 31. Aka, Essay on Relative Gravity to describe the mechanics of the universe. Balanced in the sharing of dispositions. Example, the overlapping of electron clouds in the hydrogen bond H2 are considered equidistant. Ionic bonding. In ionic bonding, radii can be larger if negative and smaller if positive. For RG, this is simply about how it refers to relative polarity, wherein defining relatively more negative and less positive, or more positive and less negative ranges. Geo.arizona.edu xstalnats100.191.jp. For RGS relative polarity, particles and subatomic particles are firstly seen as manifolds of currents that have a relative polarity. As an example, relative polarity could mean that which is more positive than something which is considered less positive. Yet that which is less positive is more positive to something that is more negative, and which is less negative to something that could be even more negative. The theorized rate of disposition in ionic bonding here for any subatomic particle must be consistent with RGS view of a fundamental manifold field. By Orion Carl Daly 32. Cookbook for the Universe. That is, in either subatomic particles, or in bonding, is in achieving a state of stability based on one of the 12-12 of 16-16 relationships of disposition illustrated below. Entity A, Entity B. Negative, negative, no bonding, no change in disposition. Negative, less negative, bonding, change in disposition. Negative, less positive, bonding, change in disposition. Negative, positive, bonding, change in disposition. Less negative, negative, bonding, change in disposition. Less negative, no bonding, no change in disposition. Less negative, less positive, bonding, change in disposition. Less negative, positive, bonding, change in disposition. Metallic bonding is seen based on the resonance range and dispositions. As current flows through a metallic bond, it is within a bandwidth expressed by the resonance of the bond in simple harmonic motion. Media.tiscali.co.uk Images feeds Hutchinson and size 001 3N055.w. This is where acceleration is proportional to displacement, but in an opposite direction, like radiant heat in electrical wire under current. Consider this with respect to RGS abstract definition. The potential energy of bodies purported as amplitude in kinetic energy and expressed as some spatial time in the form of a resonant frequency shared between them. The resonant frequency is considered a shared fundamental that is measured through their body's level of superposition. The kinetic expression is subject to the disposition of the body's potential uniquely. By Orion Carl Daly 33. Aka, Essay on Relative Gravity to describe the mechanics of the universe on chemical bonding for Law Roman 4. Equivalence and consequent evolution. Chemical bonding, from the perspective of relative gravity Rg, integrates seamlessly with Law Roman 4. Equivalence and consequent evolution. This law addresses how particles and fields evolve while maintaining symmetry and consistency across transformations, which is inherently reflected in chemical bonding processes. Below is a detailed explanation of how this principle applies to chemical bonding. Chemical bonding in the context of relative gravity. Chemical bonding is interpreted as the dynamic interaction of particle moments PMS within their respective isolated systems. The forces governing bonding, such as electromagnetic attraction and orbital overlaps, align with the equivalence principle that regulates the progression of natural systems. A. Equivalence in bond formation. Formation of chemical bonds, for example, covalent, ionic. Metallic reflects the invariant properties of forces law I, symmetry of force expressed through resonance and alignment. In a covalent bond, the shared electron density between atoms arises from the resonance frequencies of the particle moments within overlapping orbitals. Law Roman 4 ensures that these bonding interactions are consistent and predictable, regardless of position or orientation in the spatial manifold. B. Consequent evolution in bonding. The progression from unbonded to bonded states involves the minimization of energy and the attainment of relative equilibrium, aligning with Law Roman 2 conservation of energy. Consequent evolution accounts for electron-sharing covalent bonds where electron transfer ionic bonds as transformations that maintain symmetry and coherence across reference frames. C. Harmonic resonance and orbital interactions. Harmonic resonance, as described in Law Roman 3, governs the behavior of electrons in atomic and molecular orbitals. The resonance frequencies of overlapping orbitals dictate bond strength, length, and angle, ensuring that bonding interactions align with natural symmetries. D. Valence and relative force. Valence, or the bonding capacity of an atom, can be described as a property derived from the relative force Rf within the manifold. The interplay of attractive and repulsive forces between nuclei and electrons ensures that bonding interactions stabilize into predictable patterns. By Ryan Carl Daly, 34. Cookbook for the Universe. Application of Law Roman 4. Chemical bonding and symmetry. Bond geometry. Law Roman 4 accounts for the geometric arrangements of chemical bonds, such as the tetrahedral structure in methane or the planar structure in benzene. These geometries reflect the equivalence principle by maintaining consistent spatial relationships between bonding atoms. Molecular evolution. Consequent evolution applies to molecules as dynamic systems, where bond formation and dissociation represent states of transformation within isolated systems. For example, a reaction between hydrogen and oxygen to form water involves the reorganization of PMs while conserving symmetry and energy. Dynamic interactions across scales. From atomic orbitals to molecular interactions, Law Roman 4 governs the transfer and sharing of energy within the context of chemical bonding. These interactions occur consistently across different reference frames, ensuring coherence in the behavior of chemical systems. Conclusion. On chemical bonding for Law Roman 4 extends the principles of relative gravity to the molecular scale, demonstrating how symmetry, conservation, and resonance regulate chemical interactions. Bonding reflects the dynamic evolution of PMs, maintaining symmetry in forces and aligning with the equivalence and consequent evolution across all scales.